Okay, so let's go to number 4 now. So here you have the cell notation of zinc being oxidized into zinc 2 plus ion. This is the anode in the cell notation, and you have here the salt bridge, which means that the anode and the cathode are in a separate container, and then in the cathode you have a reduction of H plus to hydrogen gas, right? So the H plus will come from the weak acid. So the weak acid will partly dissociate into H plus and A minus, and it says here that the pH is 3.65. So the pH will tell you on the concentration of H plus, because pH is equal to minus log H plus concentration, right? So if you know the pH, you can find the concentration of H plus. In this case, it's 10 to the power of minus 3.65 molar. Okay, so right. So here the questions say that assume mean activity coefficient is 1 for both half cell, and the E naught of the zinc 2 plus reduction to zinc metal is minus 0.76. Okay, so to see the net of the net reaction easily, you have to, well, I recommend you to write the half cell on the anode and half cell of the cathode. Here the anode is zinc oxidized on zinc 2 plus, and the cathode is H plus reduced into hydrogen gas, right? So we know that from our lecture that this reaction is the reference reaction. It means that the potential at standard condition, or the E naught of this half cell reduction reaction, is 0, right? And the E naught of zinc 2 plus reduction is minus 0.76. Okay, this is expressed as reduction. All right. So then the net reaction would be zinc plus H plus will produce zinc ions and hydrogen gas, right? Because the zinc is more negative, so it wants to release its electron, so it wants to be oxidized, and hydrogen H plus will take that electron to be reduced into hydrogen gas, right? So the E naught cell of this electrochemical cell is E naught cathode minus the E naught anode, right? I'm using this formula, which means I'm not reversing any value. I'm taking the value as it is from the table, from the standard reduction table. So the E naught of the cell will be equal to 0. The cathode is the hydrogen cell, the hydrogen half cell, minus 0.76. So this will be positive 0.76. All right. So once you know the E naught of the cell, because the question here are what is the E naught and what is the E cell. So you have the E naught, great. Now to find the E cell, you have to go to the Nernst equation. This is the Nernst equation. You have the E of the cell equals to E naught minus RT2F. 2 is the number of electrons in the electrochemical cell reaction, and ln Q. This is Q. So Q is a function of activity of the product over activity of the reactant. So activity of zinc 2 plus, fugacity, that's the efficient pressure of hydrogen gas, over the activity of H plus. And you have to square this because you have 2 stoichiometry here in the reaction, right? And this activity of zinc is solid is 1. So it says here that you assume mean activity coefficient to be 1, which means that you can just use the concentration for the activities, and when you plug the values for E naught cell, and this is 0.05916, and now I convert this into log, so you have here the concentration of H plus square, and the concentration of H plus you get it from converting it from the pH, and then you have plug all the value, you get the E of the cell to be 0.544 volt. Right. Now the next question here is what happened to the conductivity of the electrolyte on the cathode side, where you have the weak acid here, if HA is replaced with HB. Now HB has a higher equilibrium constant, dissociation constant. So which means that it has a higher K value. So the K for a weak acid is Ha dissociating into H plus and A minus, and this is how you express the equilibrium constant of that dissociation. Now, if the K is higher for HB, it means that it will dissociate more, right? Because higher means that this term at the top will be higher, will get higher, right? Or term at the bottom will get lower, same thing. So which means that if you have a higher K, then you have a higher H plus and A minus, so more ions, right? So it means more conductivity. That's the answer for number 1. And number 2, what will happen to the E cell if you replace it with HB? And you have to go back to the Nernst expression, right? So this is the same, this is the same, and these are two are the same. The only thing that's changing here is the concentration of the H plus in the cathode, side. So if this is higher, if this term is higher, right, then the log term will be lower or more negative, and if this is more negative, negative times negative, then it will be positive. So the net result to the E cell would be positive because this term or this term is higher, right? So the potential will increase, right?